Today I am sharing with you an easy way to explain the number e or introduce the number e to the students in your classroom. So e is an irrational number whose approximate value is 2.71828182884 and so on. Since it is non-terminating and non-repeating decimal number, it is an irrational number. E is a transcendental number. What is transcendental number? A number which is not a root of any non-zero polynomial with rational coefficients, or we say which is not an algebraic number. Then e can be written as 1 plus 1 upon 1 factorial plus 1 upon 2 factorial and so on. If you add this series, you will get approximately the same number. E is also defined as limit n tends to infinity 1 plus 1 upon n raised to the power n. So today I am explaining this definition, how to introduce E using this definition. So what we have to do, we use the formula of compound interest, which all students know. It is 1 A is equal to P times 1 plus R by 100 raised to the power n. If I take P is equal to rupee 1, R is equal to 100% and R is 100 and n is number of periods. Means if interest is yearly calculated, then n is number of years. If it is calculated half yearly, then n is number of half years and so on. So let us find out A. So when I substitute, or when I say that interest is compounded yearly, if interest is compounded yearly and I take 1 year, n is equal to 1, then what would be the value of A? That is 1 into 1 plus 100 upon 100 raised to the power 1, or this is equal to 2. If it is compounded half yearly, then n would be equal to 2. In that case, amount would be equal to 1 times 1 plus, now it would be 1 by 2. Here it was 1, now it is 1 by 2, that is 50%, and number of periods are 2. So it is 9 upon 4. This is 1 plus 1 by 2, 3 by 2, 9 upon 4, and 9 upon 4 is 2.25. If it is compounded quarterly, in that case n becomes 4 and A becomes 1 times 1 plus 1 by 4 whole raised to the power 4, because number of periods would be 4 now, and this would be equal to 25 by 16 into 25 by 16, or you can say 25 by 16 whole square, and approximately I have already calculated, this is 2.4414. If it is compounded monthly, then n is equal to 12 and A is equal to 1 plus 1 by 12 raised to the power 12, and it comes out 2.613035 and so on. If it is compounded daily, see, I am increasing the value of n because I am explaining I am going to n tends to infinity. So I'm increasing the value of n. If it is daily, n is 165 and a is 1 plus 1 upon 365 whole raised to the power 365. So it comes out 2.71457 and so on. Now if I compound it hourly basis, then n is equal to 365 times 24, and this is equal to 8760. So a is equal to 1 plus 1 upon 8760 whole raised to the power 8760, and it comes out 2.718126 and so on. I have gone up to 8760 only, not even 10,000, but you can see the first two digits are same now. So if I keep on increasing the value of n, I will get more same digits. Like instead of 4, I'll get 2.718 I have already reached, then 28182. So I have already reached up to 8. So when we increase the value of n, instead of hourly I can take every second. So value of 1 plus 1 upon n. So I am reaching to this definition that 1 plus 1 upon n whole raised to the power n is approximately equal to 2.718 and so on when n is very large. And when we say n is very large, we write it in this notation: limit n tends to infinity. So you can explain or introduce E using this example or in this way, so students will always remember it. I hope you like it. Thank you.